We'll get started. Good morning. My name is Lou Tissio. I'm the Senior Director for Foundational Technologies in ITS. I am also a co-sponsor with our Chief Information Security Officer on what we call the Next Generation Network, which is this session's about. I was going through the website this morning, and I was looking at this, and I was like, wow, strengthening our network. What does that mean? And for me, it means the foundation, strengthening the foundation of our network across campus is important to me. So it was great to see this theme for this conference. So Next Generation Network, ultimately what it does is it provides a more modern, resilient, secure network across campus. But it has a bigger reach even outside of campus. The network itself is very old, and we're seeing today more and more demands on that network to help advance the research, especially research, the clinical care, and the academic areas. I was at a conference a few weeks ago called the Common Solutions Group. It was about 20 universities that attended nationwide. Out of all the places, it was in Nebraska, so I went to the University of Nebraska for this conference. And one of the topics there was talking about campus networks. There was about 10 universities that were doing very similar to what we're doing, what you're going to see about how we're going to modernize our network. Different stages, different areas, but the question was really what's driving that change. Security is huge for us, and I don't mean cybersecurity from external attacks. That's there. We have defenses for that, but it's internally as well. It's when people bring their own devices, they get on the network, there's things that are happening. There's a lot of what we call east-west traffic within the network that we don't know sometimes what's happening, or even hard to find where it is. Increased devices, IoT devices, bring your own devices, AV on the network. It just keeps getting bigger and more demand on the network, from packets to demand to bandwidth. The average student today brings between 6 to 8 devices to school that want to attach to the network. Gaming systems, iPads, phones, iWatches, IoT devices, doorbells for their rooms. I mean, so it just continues to grow and grow. Applications moving to the cloud. I could personally speak about this because I ran the Cloud Technologies Group, and the push for SaaS applications, infrastructure as a service, AWS, Azure, Google platforms, doing compute out in the cloud, big data storage out in the cloud. This is taxing our network going out of the university, and how do we handle that? Higher speeds for research, moving data across the university. We have a high-performance computing center at West Campus. They need to move big amounts of data over there for the 40,000 cores that they have to process that data. And now we're even talking about regionally. How do we collaborate with UMass and all these other institutions on the Northeast? I'm a member of a Northeast regional network team that's trying to build a much faster network throughout the Northeast. There's one on the West Coast. It's called Quilt. Very similar, but these are big demands, especially in research. Bring your own devices. I talked about that. Just attaching to Wi-Fi. We could have an average of about 30,000 people on the network in a peak day, which is quite big, just for this campus. What I'll talk about too is the technical debt, and a lot of universities are seeing this. You know, the investment in the network was never really there over the last 10 years. However, the network technology has taken leaps and bounds in the last 10 years of the technology, from software-defined networking to software-defined access to perimeters that we put in, and being able to machine learn devices that come on the network, and how do we deal with it. So I talked a little bit about the growing dependencies. So for Yale, academic delivery, right? Books online. I have a son that's going to college next year. Now they're actually now selling pages online, pages of a book that you can buy for a week, right? On a specific topic. So, you know, the demand more for video and stuff like that, and the academic delivery is getting bigger and bigger. Research, I talked about that. It's just very overwhelming for me, even just to figure out how this data gets moved. We're actually talking about how do we actually move the compute to the data using what we call containerization. You know, we build containers here, and I'm going to move those containers to UMass and let them process on their data. So the collaboration with the other universities is big. And just even on campus, we have what we call the science network. And the science network is a physical network. It's a 100-gig network, but it's only in specific buildings that are needed. Like, there's no science net in this building, but there is one getting ready for the big science building that's coming up. Clinical care, as many of you know, I mean, you know, the call centers today, we run call centers on the Yale School of Medicine side. You call them, everything's on the computer. They know who you are. They know what appointments you're going to have, what your test results look like, things like that to help you through. And even to the point where these doctors are in the Yale Health Plan, where they have carts and stuff that need to connect to the network, things like that. So no more paper anymore. We were just talking the other day about Milford Hospital. Yale New Haven Health Services bought Milford Hospital. Well, they were never computerized, as you know, to the point where we are today. I mean, they have basic computerization, but a lot of their records are manual records, which is they're going to be spending quite a bit of money on getting Milford Hospital up and running. And of course, the cultural heritage side for worldwide scholars. The biggest challenge for us in this area is that digital-born collections are very important, and how do you preserve those? Where do you preserve those? Where, you know, you have to save those in like 8 different places around the country sometimes, right? So I'm working actually very closely with the library on trying to define, do we need a cultural heritage digital collection type of network built into our architecture, and what does that mean for the museums as well as the libraries that are tied to it. Very simple. We have a very aging network, very old, mixture of many, many different technologies. It's a complete comprehensive replacement of the hardware throughout the network, and I'll show you the numbers, what that means. The security side of this is going to be built into the network. It's a different type of model on how we actually intercept different things that are happening on the network, how we can pick up, you know, a device that's across campus and say, ooh, that's playing really badly. I just want to put it over here. Put them in a different network that's kind of safe. Where today, a lot of times you'll see part of my team running out of the building, try to go find that in the building, right? So it's very, very manual process. And we'll talk about the number of networks. So the key thing really is, for me, is the reliability, the resiliency, the visibility of this network. Pictures tell 1,000 words here, and this is not the worst one. I'll just tell you this. You know, that pipe, I hit my head on it when I went to go see it. So, you know, we have the physical state of the network. Just even the closets that are around campus are in really poor shape. They're not managed properly. There's a lot of work that needs to be done just in the conditioning of some of these old buildings that we have to do. And the project itself, you know, I'll give you a little preference on how this project happened. It's a 5-year project, and I spent probably 8 months working with the budget advisory groups, the financial committees, the business office, all the way up to the board of directors on presentations for this. And we've been fully approved, not committed, but fully approved to spend $50 million to replace this network. So it's a big number. All right. As you can tell here, 55% of the equipment is beyond its recommended service age. The segmentations are concerned to the security side of things. Just standards in general. I mean, we probably have about 4 different types of manufacturers of switching equipment and Wi-Fi points. So here are the key deliverables. So we need to remediate about 1,400 rooms, closets that connect all the floors in one building. So this could range from a complete redo to the room, to just wiring, to just even securing the room. We have rooms where they're just in closets. We have a room that's to get to it, you have to go through the women's restroom. So it's very difficult to even keep control of these rooms just from a physical standpoint. Some of them don't have key locks on it or proxy locks on it. We find people put things in it like a microwave in the room or something like that. So we have to take better control of these rooms. And everything from even air conditioning and power and fiber connections to specific rooms. So there's a very lengthy process here, a very long assessment that has to go on with this, but it's going to go on for the next 5 years, just assessing and remediating the rooms. We're replacing about 9,000 devices. That includes Wi-Fi devices as well. The Wi-Fi devices, we have actually a big investment in newer Wi-Fi devices, so we'll let them age out and replace them as they get replaced over time. Consolidating 5 networks, and we have focused on 5 networks only because those are the 5 biggest networks. We have many other physical networks, and these are physical. So if you go into a closet, you will see a rack of switches 3 times, let's say. One for facilities, a facilities network, one for a public safety network, one for a campus network. That's going to come together through software-defined networking, right, into one architecture. Role-based access, you'll see in the back part of as we go through the presentation, that role-based access is defining who you are and what you get on the network. There's researchers who are going to need 100 gig connections, and we can define that for a researcher, where you can have the administrative office that just needs access and maybe needs like a 5 gig connection versus a 100 gig connection. Who you are, where you are, is going to define your different roles. If I'm a clinician, I want to be able to move from here to Yale New Haven Health and be able to use my same ID and not have multiple IDs. That's the role-based access piece of it. And automating cybersecurity responses, I spoke a little bit about it, but it's more machine-based responsing versus manual responsing. So I talked a little bit about these in the last slide, but seamless user experience, no matter what profile you're in, if you're just a student where you deal with low-risk data, or if you're a clinician who deals with HIPAA, or a researcher that deals with different other like FERPA or EPHI data, though it's going to be seamless. You go here, you go to a different network, over the Med Campus, which is a different network, and you'll have that seamless connection to all your resources. Even if you're VPN in, it'll be the same thing. You'll just be looking like a remote site onto the network. Faster speeds are going to go 10 to 40 times faster. I mean, really, the network it's not the fiber, it's not the cabling in the network, it's the switching, right? So we change these switches to a much more robust, faster switching technology. Fewer network disruptions. I've been in this position now for a little bit over a year. I made it very visible on weekly updates about outages that are happening around campus, all the way to the provost. It's like this. This week we had 8 outages, 3 buildings down. And it was important to do that because we never did that before, and giving that visibility really shows the concern that we've had. Machine speed detection for breaches. Again, built into the network, there's this security-defined access, and they call ICE, which is another piece of it, that and DNA Center, which is another piece of it, that is going to help with the machine detection and visibility of where things are happening. Like I said, it's very, very difficult today to actually find things. Here's a very high-level schedule. We spent a good part of FY19 really from a programmatic perspective, building a team. We are moving to all Cisco technology. I got a lot of questions about that. We actually have Cisco here on site for the next 2 years. Their advanced services and engineering teams are here working with the teams. We have a number of different providers that work with Cisco that are here to help us with deployment and architecture. So we spent this year really programmatically bringing the team together, understanding what it means, and working on the design and architecture piece of this program. We're starting with some pilot buildings, probably, I think, very soon, this summer. 25 Science Park is going to be the first one because we're going to eat our own dog food and learn from that. But we're taking 2 administrative buildings on Central Campus here. And then there's been a little bit of a turn of the tides because of some recent things that have happened with the med school campus network. But we are accelerating a deployment on the med school side to correct some major issues there. So over the next, once we get through the pilot cycle, I think once we get through FY20, we'll have a whole deployment plan ready to go for the next few years, and it's just really going through each of those buildings. Up front of this, there's a couple other work streams, like I mentioned. We're looking at the whole fiber plant on the university, making sure we have diverse connections, and did I shut this off? I think it went out. I'll speak louder. Looks like it went out. We're looking at the rooms and stuff, so we're trying to get that what we call layer 1 set in place before we start putting in the electronics. Okay? So we're defining this in 2 different releases. The foundational release, which I mentioned before, is focused on resiliency, reliability, stability, visibility, and hopefully when we do that phase, my emails each week to the provost on the down buildings will reduce down to nothing, because that's really the primary focus of this. And then moving into the advanced security side of things. We have a lab set up now at Science Park, and we're going to have teams of people, public safety coming in, trying all their devices. Facilities has an enormous amount of devices just to run a building. They need to test all those in the lab before we roll out and config those. When you plug something into the network, if it is not defined through a configuration, it will not be allowed on the network. It will be put in a space that has to have a config made for it, type. Yeah, right? So we're hoping that over time that will be easily done to allow those devices. But we do get devices plugged into the network that spew a lot of different traffic that hurts our network today. So where are we? I spoke a little bit about this. Designs are 80% complete. Our teams are still building, but the core team has been working the last year on the implementation side of things, as well as the pilot buildings, and then looking ahead for what the next couple of years look like. What's next is, again, the detailed migrations plans. We're going to focus out on West Campus in the beginning, probably as the normal project begins. only because we have a little more flexibility with the Layer 1 piece of West Campus. So from a physical plant standpoint. Use cases, we need to build use cases. That's one of our next steps as well. Meeting with the research community, meeting with the clinical community, meeting with the facilities community, and understand all the use cases that need to happen for those areas, and also the academic side. Right? That's all I have. Well, I'll be around for a little while if there's any other questions, and thank you very much, and enjoy the rest of the day.